Good morning, students. Today we're going to start a new chapter that is chemical bonding and molecular structure. Students, we have done this chemical bonding in class 10th also. Your basics are clear in 10th class. Just recall your basics, right? So, my first question is, what is chemical bond or what is chemical bonding? The atoms of molecules that are linked together through a reaction known as chemical bonding. Or we can say a force, a chemical bond is a force that holds the atom together. The force of attraction between the two atoms is known as chemical bond, right? And what is chemical bonding? The atoms of molecule are linked together through a reaction. It's known as chemical bonding. You can see that, right? Now, one scientist was there. That was Lewis. And he gave a Lewis dot structure, right? Lewis dot structure can be represented by dots itself, right? How? Just see, here are the elements showing from 1 to 20, which are showing the Lewis dot structure. Like hydrogen has atomic number 1, so number of valence electrons are 1 only. So Lewis dot structure, according to Lewis dot structure, how we can represent hydrogen, that is H dot. Similarly for lithium, for helium, beryllium, boron, and so on, right? Now my question arises, why two atoms attract each other, right? Why there's a force between two atoms? What is the need to make a bond? So to understand the concept of bond, why two atoms they attract together to form a bond between them, is given by octet rule. Students, we have heard about octet rule in class 10th also. Octet rule states that element gain or lose electron to attain electron configuration, or we can say the nearest noble gas configuration, or we can say stability. Here, stability is very important. If any element is stable in nature, it will not react. To attain the stability, they attract each other and they form bond between them, right? So this was a octet rule, right, which states that an element is stable only when its octet is complete. Exception is there, that is for hydrogen and helium. You know that hydrogen and helium has only 2 electron in its valence shell, so they complete their duplet instead of octet. Now, my next question is, why do elements follow the octet rule? Atoms follow the octet rule because they always seek the most stable electronic configuration, right? It means they need stability. Following the octet rule results in completely filled S and P orbital in an atom outermost energy shell. For low atomic weight elements, the first 20 elements are most likely to adhere to the octet rule, right? It means mostly, no doubt, all the elements follow, but mostly the first 20 elements follow or adhere to the octet rule. But there are certain limitations for the octet rule. And what are these limitations? These limitations are the incomplete, we can say exceptions to the octet rule. First of all, I'll deal with the limitations or exceptions. We can say the incomplete octet of central atom. It means there are many compounds, or we can say some of the compounds whose central atom is having less than 8 electrons. So stability means it should have 8 electrons, but here many compounds formed, instead of they are having less than 8 electrons, right? And this is exceptionally for the case of element less than 4 valence electron, like lithium chloride and boron chloride, right? BCl3, BeH2, LiCl. So these elements like lithium, beryllium, boron, they have 1, 2, or 3 valence electron only. Their octet is not complete. So how the formation of compound is possible? So the answer was not there. That was the biggest limitation. The second one was expanded octet. Expanded octet means having more than 8 electron in its valence shell. When central atom have more than 8 electrons, this is against the octet rule, because according to octet rule, the element must have 8 electrons, not less than that, not more than that. But some of the compound still exist having more than 8 electrons. So example of expanded octets are PF5, SF6, H2SO4. Similarly, for the odd electron concept, like I have given the third point NO2, here in this molecule an odd number of electrons are present, right? And this is again not satisfying the octet rule. There are some other limitations also, students. Drawbacks, we can say that it is not clear that octet rule is based upon the chemical inertness of the noble gases. However, noble gases also combine with oxygen and fluorine to form number of compounds. According to octet rule, noble gases have completely electronic configuration, right? They are our nearest noble gases, but still they form compounds. Why it is so? Answer is not there. That this theory does not account for the shape of molecules. It only tells us about the stability, but does not support for the shape of molecule. It does not explain the relative stability of the molecules, which we'll discuss in our later lectures. Now, students, we have heard about the type of bonds. Basically, we have three types of bonds. Here I have shown you two types because in your plus one syllabus, we have only two types in your NCERT book. But basically we have three types. One type is an ionic bond known to be electrovalent bond. Second is covalent bond. And the third is coordinate bond, or we can say codative bond. So I'll talk about the two of them. One is ionic bond. You know that ionic bond is formed by the complete transfer of electrons between metals and non-metals. And covalent bonds are formed between, or covalent bond is formed by the sharing of electrons between two non-metals. Now, as we know, this is one of the example of ionic or electrovalent bond. An ionic bond is formed in a compound when the electrons from the outermost shell of an atom are actually transferred to the outermost shell of the combining element. Here I have given that one example to you, that is sodium chloride, and you know it very well. You know many compounds which undergo ionic bond formation, right? Next is a covalent bond, students. Covalent bond means a bond is formed by the sharing of electrons, right? When it cannot transfer, because the transfer of electron take place, the transfer can be by one electron, by two, by three, but not more than three. So in that case, only the sharing is possible. So we have three types of covalent bond, right? One is single covalent bond, second is double covalent bond, third is triple covalent bond. So when two electrons are shared between the atoms, like I have shown to you in the case of hydrogen, it will be represented by one single line, and it is known as single covalent bond, or known to be sigma bond. The second is a double covalent bond, when four electrons are being shared by two atoms, right? And it is being represented by two short lines, and it is known to be double covalent bond. The next is triple covalent bond, when six electrons are being shared, or we can say three unbounded electrons are being shared, and it is being represented by three short lines. They are known as triple covalent bond, which is being shown by nitrogen atom. Similarly, not only the two similar non-metals, one dissimilar, or we can say more than two non-metals can combine to form a covalent bond. Here's your example. Other covalent molecules, right, like methane, and as in the water, we have many ammonia, we have methane, ethane, we have ethine, we have many compounds, right? Thank you so much.